Chapter 4, Section 4 is about scatter plots. In this section, we're going to go over how to create a scatter plot, the different types of scatter plots, and then how we can also use data from our scatter plot to create what's called the line of best fit, which would be like creating a prediction equation that would maybe help us see what was going to happen in the future if our data kept going in the trend that it was showing on the graph. So for some vocab I want to go over first with scatter plots, just so that you know what these words mean. If you hear me say them or you see them in a problem later, that you understand what it's talking about. The first vocab word is something called bivariate data, which just means that it's data that has two variables. So for example, hours worked versus money earned. So the more hours you work, the more money you would earn. There would be other ways that you could compare two sets of data as well. So any problem that is trying to show a relationship between two types of data or something like that would be an example of that bivariate data. Now a scatter plot is a graph that consists of ordered pairs. They usually are not going to create a perfect line or shape, and that's why they're called scatter plots, because the points are kind of all over the place. But they usually have like a trend. So most of the time scatter plots will go positively or negatively. When you're kind of looking at like the correlation that the data has with each other. Now this line of best fit, that's that line that you're going to want to be creating an equation for that would fit most of your data points pretty closely. They're not going to go through all of the data points because again it is scattered, but this would at least give you a good idea of maybe where the points are at or being able to find points that are in the future. Same thing would be considered like the prediction equation down here. So line of best fit really helps you create your prediction equation. Interpolation and extrapolation, those would just be able to like predict values that are going to be going either inside of a certain range or outside of a certain range, depending on what exactly you're trying to find on your scatter plot. The three types of scatter plots that you're going to see would be positive, negative, and no correlation. So positive correlation means that the data is going up, so it almost appears to have a positive slope. Negative correlation means that your data is kind of going down over time. And no correlation just means that the data is kind of too scattered, so maybe you don't have enough data points to kind of show you what the data would be doing over time. Maybe you didn't sample a big enough group, or the data that you're looking at really doesn't have any relationship with one another, and so it's too scattered, it doesn't really make any sense for it to have a positive or negative relationship. We're going to take a look at this example here, and we're going to create a scatter plot for the data here in the table, and then we're going to use our data to create an equation for the line, and then be able to predict how many bushels will be sold if the price is $3.90. So we're going to use our equation that we create to help us figure out what's going to come next. So the steps that you want to follow when you're doing a scatter plot is you're going to want to plot your points. And then to create your equation, you're going to need to pick 2 points that you feel best represent your data. The only thing you want to be careful with here is that you don't pick points that are too close together. So you want them to be maybe spread apart. So pick one from the kind of start end of your data and then the end values. You don't want them to be like too close to each other on the graph because it's not going to give you a really true representation of the data points. Then you're going to want to be able to use those points to create your equation of your line. And we actually did some of this back in section 2. So you're going to want to find your slope and then use point slope form, which remember is y minus y1 equals m times x minus x1. So we'll use that form to help us create our equation. So if you remember when we did that in section 2, we would find our slope first, and then we would use our slope and we would pick one of our points to plug it into our equation. And then we would solve for y, so we would eventually get it back to y equals mx plus b form to get your prediction equation or your line of best fit. And then what we would do is use that equation to kind of estimate what would come next. And then we would check to see if that answer makes sense. For scatter plots, I would say what probably takes you the longest amount of time is creating the scatter plot itself. Because the data in some senses can be really kind of hard to figure out like what you want your scales to be. So when you're looking at the table of values that they give you, like for this example here, we've got dollars and then we've got the amount being sold. So you really have to kind of decide, how do I want to create my X and Y axis? Like what are the numbers I want to use? What's my scale that I want to go by? You know, do I want to go by 2s, 5s, 10s, something like that? And you'll just kind of have to look at your numbers and see kind of what happens over time to know what's the best thing. So I'm going to get this one set up here and just kind of guide you guys through what I would be doing if I were in your case and I was trying to create the scatter plot. First thing that I'm going to do is label my X and Y axis here. Let me just make sure I'm giving myself enough room. I think I'm going to come out a little bit farther here. Okay. So I know that I'm going to have to kind of go up and down, but you guys should have a packet in front of you that allows you to kind of see the data that we're looking at here to create this scatter plot. Now what I'm going to do is down on my x-axis, this is going to be my cost for your bushels. And then over here on the y-axis is going to be the number of bushels that were being sold at that price, and that's in thousands. So looking at my cost, my data points up there, it starts at 384 and it goes up to 387. The really nice thing about scatter plots is that you don't have to start at 0, 0 and go like 1, 2, 3, 4, 5. You can change the scale however you want. So I'm actually going to bump mine up. Instead of going from 0 to 1, I'm going to go 0 to 3. Now in order for me to kind of keep track that I did that, we just kind of draw like a little squiggly line on our axis here, just to kind of show like I'm kind of skipping over some points on my scatter plot, so I'm kind of breaking the way that my traditional x-axis would be here, and instead of starting at 1, I'm starting at 3. And then what I'm going to do is each one of these squares is going to be $3, and like the next one would be $3.10, $3.20, 30 cents, 40 cents, and then I'm going to do 3.5 here for $3.50. Now I'm going to keep that trend going. So here's 360, 370, 380, 390, and then here's 4, 410, 420, 430, 440, 450, 460, 470, which you could keep going if you'd like to, up to like 5. We really won't be doing much over here though, because the highest number I have is 3.87. Now for my other axis, again, I'm going to break this one because I'm talking about my bushels that were sold. So looking back up at my data points here, so looking at this second set of numbers, the smallest number I see is that 28, and the biggest number I see is 50. So again, I'm not going to start at 0 on my axis here. I'm probably going to jump up to like 20. And then I'm going to go up by 2s. So first one's 20, then 22, 24, 26, 28, 30, 32, and so on. And I'm going to stop at 52 because, like I said, the biggest point I saw there was 50, so I don't really need to worry about doing anything above that. Now, this next part, once you've got your scales done, the next part is going to be probably, like I said, what takes the most time is plotting those points. So you're going to have to go for that first one, 384. So you're going to have to kind of think about, okay, down here, 380 is like right in this area, if you can see where my pen's at. I'm going to go a little bit over that for 384, and I got to go all the way up to 50 and draw a point. And so you'll have to just kind of estimate where you think it's at. This scatter plot maybe isn't going to be designed where your points fit perfectly. And then you're going to have to do that for all of these points. So this is what's going to take us the most amount of time on this problem. So I'm going to be graphing the rest of the points up here. Why don't you guys go ahead and do the same? So look at those data points that we have up there in our table. So like the next one I'm going to graph is at 366.47. So I'm going to go over to 366. So go a little bit over 360 and then go up to about where you think 47 would be. And just draw a point there. Again, I don't expect these to be perfect or to match mine exactly. You're going to have to just do your best at estimating where you think they're at. But so go ahead, and as I'm plotting my points, I want you to plot your points at the same time as me so that we can hopefully be finishing up around the same amount of time here. Okay, if you need more time to still plot your points, go ahead and pause here, and then when you're finished, go ahead and keep watching, because now what I'm going to show you guys is how we create our equation. Like I said, the biggest, maybe the tedious process of these problems is doing that. Like, you got to create your scatter plot and actually put the points on there. Now, yours may not look exactly like mine, and that's okay. And then you're able to at least kind of see that it should look somewhat the same. Like, there should be something that looks similar to mine here. So I can kind of see that this has like a negative correlation. You know, the more cost per bushel it is, the less they seem to be selling. So the more expensive it starts to be, the less product that they're able to push out. So this would show me like a negative correlation. What I need to do now is create an equation here. So coming back to our data points, we need to pick 2 points from this table. Now, I said earlier that when you're doing this, you don't want to pick 2 points that are too close together. You want them to be somewhat spread apart so that you can create a true line of best fit. What the line of best fit would look like is if I were to try to draw a line that like came down through this data, something like that. It's not going to hit all the data points, but it's going to be close to most of them. So I would want to maybe think about where's that line at. So if it helps you to kind of envision just kind of drawing it in there, and then picking some points that would be close to that line, or maybe even on that line, would be good points to pick for you to create the equation of best fit. Now, you don't want to pick 2 points too close together, so make sure you kind of spread them apart. So the 2 points that I decided to pick here was the 360.49, so that point, and the 396.28. Now, they look close together on my table, but on my graph, they're not. They would be like on opposite. One would be up here at the top, one would be down here at the bottom. So as a coordinate, we would have 3.6049 and then 3.9628. Now that you've got your 2 points, we're going to go back to what we were doing in section 2 and kind of follow that process to help us write this equation. So step 1 is to find your slope. So remember, slope is when you subtract your y's on top and you subtract your x's on the bottom. So I'm going to do 49 minus 28, and I'm just choosing to go this way. You could have done 28 minus 49 if you wanted to. And then on the bottom, it would be 360 minus 396. So that comes out to be 21 over negative 0.36, which if we divide that out, that comes out to be negative 58.3 repeating, which you might want to just round to negative 0.3. Now this is going to be your m value. So that's like one piece of information that we needed to find. Now we want to pick a coordinate, and it doesn't matter which coordinate you pick. I'm going to go ahead and just use that first one, the 3.6049. And taking those 2 pieces of information, we're going to write our equation now. So we're going back to that point slope form, which looks like this. So we're going to do y minus the y value, which is that 49, equals that negative 58.3 goes in for m. And then it's x minus that 3.60. And I'm just going to drop the 0 here. Now to write our equation, we're going to want to get this in slope-intercept form, which means that we're going to want to solve for y. So the first thing I'm going to do here is distribute. So we've got y minus 49 equals negative 58.3x. And then negative 58.3 times negative 3.6. We want to multiply those. So that's going to be plus 209.88. Then we want to move this 49 over here, so we do that by adding 49. So this leaves us with y equals negative 58.3x, and then plus 258.88. So there's your equation for line of best fit. Now, it's messy looking. We don't have great numbers, and a lot of that's just because of those points that we're dealing with aren't nice, clean coordinates like 2, 4 or negative 1, 5 would be. It's the same process of what you guys did in section 2. It's just a little bit uglier because of those numbers that they're giving us here. But so this would be our equation that we could use to represent this data. Now, like I said, this doesn't necessarily include all the points that we see here, but it would be pretty close. Like if I wanted to come up and grab one of those costs, like let's say we look at 363 here. If I plug in 363 for x, so if I take negative 58.3 times 363 and then add 258.88, I get 47.25, so 47.2. That's pretty darn close to 47. So I would think that that's going to be the best line that's going to show this data. Like I said, you're not going to maybe get the exact value that you see in your table, but you should get something that's pretty darn close to it. Now, the other thing that they did want us to do in this problem, if we come back up here, it says predict how many bushels would be sold if the price was $3.90. So to do that, coming down here to our equation, we're going to put $3.90 in for x. So we're going to take that negative 58.3 times 3.9, or 390, or 3.90 if you want, and then plus that 258.88. And then we just type that into our calculator. And that should come out to be 31.5, or they might round it to 32, just because our numbers up there seem to be in whole numbers. And that would be 1,000 bushels. Which, if we looked at my graph here, 390 would be right here. And so I would think that that's close to 32, which would be right there. So $3.90, 32, that would be my point that I predicted. It's pretty close to that line that I had drawn. So it probably makes sense that that would be maybe about the amount of bushels that they would sell, because it kind of lines up with the rest of the data. So, like I said, the biggest amount of work, or like the longest process, is really getting the scatter plot created. Writing the equation, because you're dealing with data points, which are talking about cost of things, number of things being sold, your numbers probably aren't going to be as nice as they were in section 2. But this whole process of writing that equation, we've done that before. None of that should have been new, like finding slope, point slope, slope-intercept, all of that you have done before in this chapter. It's just now applying it. It's taking these ideas that we teach you guys about in class and showing you how it might be used outside of the classroom. So that's our example there and our prediction for what would happen in the future.